Class 12th Chemistry Coordination Compounds. In this video, we will discuss about bonding in metal carbonyls and importance and applications of coordination compounds. First come to metal carbonyls. The homoleptic carbonyls, that is compounds containing carbonyl ligands only, are formed by most of the transition metals. Some examples are here. Tetracarbonyl nickel 0. This 0 is the oxidation state of nickel in this complex, and its formula is NiCO4 and its geometry is tetrahedral. Pentacarbonyl iron 0. Its formula is FeCO5 and its geometry is trigonal bipyramidal. Hexacarbonyl chromium 0. Its formula is CrCO6 and geometry is octahedral. This is decacarbonyl dimanganese 0. Formula is Mn2CO10, and this is the structure of this. In this structure there is a manganese bonding is there. Octacarbonyl dicobalt 0. This is CO2CO8. When you write the formula, be careful about small letter and capital letter. This is C is capital and O is small. This is the cobalt. But when you write both capital, this is carbonyl ligand. And in this complex, there is a bond between cobalt and two CO groups act as bridging groups. Okay. Now bonding in metal carbonyls. Metal carbon bond in metal carbonyls possess both sigma and pi character. Metal carbon sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into a vacant orbital of the metal. Metal carbon pi bond is formed by the donation of a pair of electrons from a filled d orbital of metal into vacant anti-bonding orbital of carbon monoxide. The metal to ligand bonding creates a synergic effect which strengthens the bond between CO and the metal. From this diagram, we try to understand bonding in metal carbonyls. This is the carbonyl group, and this carbonyl group has this lone pair of electron. This is the metal atom, and this is empty d orbital. This lone pair of electron is donated to this empty d orbital, forming a sigma bond. At the same time, this represents the filled d orbitals to metal atom, and it has one pair of electron, and this represents the empty or vacant anti-bonding pi orbital with carbon monoxide. This pair of electron which is present with the metal atom, this is donated to empty or vacant anti-bonding pi orbital of carbon monoxide, forming a pi bond. Pi bond is formed by side-wise overlapping. Okay. That's why this is pi bond. And in this way, this is synergic bonding is taking place. Synergic means bonding is the more formal name for bake bonding. Actually, carbonyl group form a sigma bond with the metal atom by donating its pair of electron to the empty orbital of metal atom. But at the same time, the metal atom has a lone pair of electron which is bake donated to the vacant anti-bonding pi orbital of carbon monoxide. This is called bake donation or bake bonding, and this is also known as the synergic effect, which strengthens the bond between CO and the metal. Importance and applications of coordination compounds. Coordination compounds find use in many qualitative and quantitative chemical analysis. The familiar color reactions given by metal ions with the number of ligands are used to detect and to estimate the metals. Examples of such reagents include EDTA, DMG, dimethylglyoxime, alpha nitroso, beta naphthol, cupron, etc. Actually, these reagents react with the metal ions and produce some colored complexes, and from that color we can identify metal atom or metal ions. Hardness of water is estimated by simple titration with Na2EDTA. As we know, hard water contains calcium and magnesium ions. These calcium and magnesium ions form stable complexes with EDTA, and the strength of or concentration of these stable complexes can be determined by titration. In this way, we can find out the hardness of water. Extraction of metals like silver and gold make use of complex formation. For example, gold combines with cyanide. The cyanide is either in the form of sodium cyanide or KCN, potassium cyanide. In the presence of oxygen and water to form the coordination entity AuCN2 negative charge in aqueous solution. Gold can be separated in metallic form from this solution by the addition of zinc. When we add the zinc to this solution of this complex, we will get the gold. In this way, this is used to obtain the gold and silver. Purification of metals can be achieved through formation and subsequent decomposition of their coordination compounds. Actually, in the chapter metallurgy, there is a purification technique, vapor phase refining. And in this vapor phase refining, for specific nickel, if we use, this is Mond process. In that Mond process, impure nickel is converted into NiCO4 by treating impure sample of nickel with the CO. Then nickel will form this, and this is a volatile complex. That's why this is decomposed to give pure nickel. Coordination compounds are of great importance in biological system. The pigment responsible for photosynthesis, that is chlorophyll, is a coordination compound of magnesium. Hemoglobin, the red pigment of blood which acts as oxygen carrier, is a coordination compound of iron. Vitamin B12, this is cyanocobalamin. This is the anti-pernicious anemia factor, is a coordination compound of cobalt. Okay, actually this pernicious anemia is caused due to the deficiency of vitamin B12. Okay, to recover this pernicious anemia, vitamin B12 is given, and vitamin B12 is a coordination compound of cobalt. Coordination compounds are used as catalysts for many industrial processes. Examples include rhodium complex. This is RHPPS3 3Cl. Its name is Wilkinson catalyst. This is called Wilkinson catalyst. This is used for the hydrogenation of alkenes. In electroplating, articles can be electroplated with silver and gold much more smoothly and evenly from solutions of the complexes AgCN2 negative and AuCN2 negative than from a solution of simple metal ions. In black and white photography, the developed film is fixed by washing with hypo. This hypo is a sodium thiosulfate. Okay, and this hypo solution dissolves the undecomposed AgBr to form a complex ion. This complex ion is formed when undecomposed AgBr react with the hypo solution. In this way, the developed film is fixed, and we will get the negative in case of black and white photography. Use of chelate therapy in medicinal chemistry. Excess of copper and iron are removed by the chelating ligands D-penicillamine and dysferrioxime B via the formation of coordination compounds. EDTA is used in the treatment of lead poisoning. Okay, actually this EDTA reacts with the lead and form a complex, and this complex is soluble in water, and this is removed from our body with the urine. Coordination compound cisplatin, this is used in cancer treatment. Thank you students. Subscribe my channel to get the new videos of next chapter. Thank you.